So this video will go over the 1.1 to 1.3 video where the first section was all about simplifying expressions. So let's take a look. In this first problem, we are basically going ahead and combining like terms, right? So if I look, I have 8x squared, I have no other x squareds, I have negative 3x, 9x is a like term with it, and I have negative 2, and then minus 5. All of those are like terms, right? So 8x squared has nothing, so I bring it down. But then when I do negative 3x plus 9x, I get plus 6x. Remember, when you combine like term, you do not change the variable expression. Then negative 2 minus 5 is minus 7. Okay? Number 2 is just a distributive property. 4 times 3x gives you 12x. 4 times negative 2 is minus 8. These cannot be combined because they are not like terms. Number 3, remember, negative 3x times 2x gives you negative 3 times 2 is negative 6. X times x is x squared. Then negative 3x times 4 will give you negative 12x. These are not like terms, so they cannot be combined. The next one, first I'm going to distribute the 5. 5 times 2x is 10x. 5 times negative 3 is minus 15. Then I'm going to go ahead and distribute the 6. 6 times 4x is plus 24x. And 6 times 1 is plus 6. And now 10x plus 24x is 34x. And negative 15 plus 6 would give you minus 9. Nothing else can be combined. Now, when we multiply binomials, remember what we said. Each term in this quantity has to get distributed to the second one. X times x gives you x squared. X times negative 7 is minus 7x. Then 3 times x is plus 3x. And 3 times negative 7 is minus 21. If I look, I can combine like terms now. X squareds go together. The x's go together. And the constants go together. So we get x squared minus 4x minus 21. Okay? The next one, 2x times 3x is going to give you 6x to the second. 2x times negative 5 is minus 10x. Then negative 3 times 3x is minus 9x. Negative 3 times negative 5 is plus 15. So now you have x squared here. So you have 6x squared. But when I combine negative 10x and negative 9x, minus 19x, and then plus 15. Okay? So that first section, there's a video that goes over simplifying expressions. You need to know how to do those. Okay? The next one, right away, whenever we evaluate g of 4, right? G of 4 tells me I'm going to use function g, and everywhere I see an x, I'm going to kick it out and replace it with a 4. So g of 4 is equal to 4 times 2, right, to the 4th power. Well, that's going to give me 4 times 16, which gives me 64. You could also plug that in the calculator exactly the way you see it. Okay? Number 8, h of 3, right? That tells me I'm going to use function h, and everywhere I see an x, I'm going to replace it with a 3. So, h of 3 is equal to 2 times 3 squared minus 3 times 3 plus 5. So remember, 3 squared is going to give you 9. And then 2 times 9 will give you 18. Minus 3 times 3 is 9. So minus 9 plus 5. 18 minus 9 is 9. Plus 5 is 14. Again, you can plug it in the calculator exactly the way you see it. So when I do f of 3 plus g of 1, basically first I'm going to take function f and evaluate it at with an x value of 3. So f of 3 would be negative 2 times 3 minus 3 plus 4. That gives me negative 2 times 0 plus 4. What is negative 2 times 0? 0, and 0 plus 4 tells me f of 3 is 4. Now g of 1 is 4 times 2 to the first power, which is going to give me 4 times 2, which is 8. So g of 1 is 8, and now what is 4 plus 8? That is 12. Okay? Now the next one, determine if the explicit rules represent a linear, exponential, or linear function. Circle the function type. Write the recursive rule for the function. Remember, anything that's in the form a times b to the x, that's going to be exponential, right? And when I look at this, remember, a is your initial value, and b is your common ratio. So right here, when I go to write the recursive, the first thing I have to do is find the initial value. Well, if I evaluate f of 0, 4 times 3 to the 0 power will give me 4 times 1, right? Remember, anything to the 0 power is 1. So basically, f of 0 is equal to 4. Now, f of x equals, I'm going to take the previous term, f of x minus 1, and I'm going to multiply it by, what's my common ratio? My common ratio is 3. And that's your recursive rule. Okay? So the next one, whenever I see x times x plus 4, it doesn't look linear and it doesn't look exponential, so it's probably going to be quadratic. So what do? I distribute to c. X times x is x squared plus 4x. Is that quadratic? Yes. So now I'm going to evaluate this function, say f of 0, which is going to give me 0 times 0 plus 4, which is just going to give me 0, because anything times 0 is 0. So f of 0 is equal to 0. Now with the quadratic, it's a little different. You're going to get 0, 0, then it's going to be 1, and then 1 plus 4 is 5, so 1, 5. Then 2, what is that going to be? 2 plus 4 is 12. Then 3, 21. What I need to find here is that second difference. 5, 7, 9. That second difference is 2. So you know it's the previous term plus 2x, and then we have to see what the constant would be. So if I looked at this right away, if I do f of 2, that is 12 equals 5 plus, what was that, 4 plus c. Well, 9 plus what would give me 12? So it's plus 3. And that would be your recursive rule for the quadratic. That there is a difficult problem. Okay? Now the last one. If I look, here's my slope times x minus x1 plus y1, which tells me I have an ordered pair here. So I could right away, if x1 is 1 here and y1 is 4, that tells me f of 1 is equal to 4. Now, isn't this my common difference or slope? So f of x equals my previous term plus, or sorry, in this case it'd be minus 9. Remember, this number here is your common difference. Okay? Number 13, d of 4. All I have to do is look on the x-axis for 4. And I'm going to go up and see what the corresponding y value is. When x is 4, y is 5. Done. How long does it take him to get 11 miles from home? If I go up here, here's 11, and if I go over, it took him, if I go down, 5 hours. Okay? How long did it take him to get home after he reached his destination? Well, once he reached his destination, I took 2 answers. Once he reached his destination here, the furthest he went from home is his destination. So if I look, it took him from 5 to 10, which is 5 hours, but what I said is he was at his destination for about a half hour before he went home. So truly, it should be 4.5 hours, but I accepted 5 hours also. Now, what does D of 3 mean? Well, remember, the input is time, the output is miles from home. Therefore, after 3 hours, he was 4 miles from home. Okay? Next couple. Determine if they're linear, exponential, or quadratic, and then write the recursive and explicit rule. So, right away here, if I look here, I'm looking for a common difference, common ratio, a second difference. So here you went, there's no common ratio, so you went up 6 here, you went up 10 here, you went up 14 here, and then, what'd you go up here, 18? So right now you have a common second difference of 4. So that tells you this is quadratic. Now, let's just do the explicit or the recursive rule first, right? So right away, f of 1 is equal to 5. Then f of x is equal to the previous term plus, remember, it's the common difference times x plus 4x. So now we have to plug a point in. So if we know this, we have to find c. So let's plug 3 in. So f of 3 equals f of 3 minus 1 is 2 plus 4 times 3 plus c. Well, f of 3 is 21 equals f of 2 is 11 plus 12 plus c. This gives me 23. So what do I have to do to 23 to get 21? I have to subtract 2. And that would be your explicit rule. Or your, your recursive rule. Okay? Now, basically, to get the explicit rule, in this case, you basically have to play with numbers. It ends up being 2x squared plus 3. And it's just, how can I manipulate x to get the output y? Okay, I did count that as bonus. So the next one, if I look, what am I doing here to here to here? Okay, well, from 6 to 12, I went up, I multiplied by 2, or I went up 6. There's really no common factor for, you can't multiply 12 by anything to get 32, but this went up 20. Then it went up 18. Is there any pattern here? No. So this is neither type of function. Okay? The next one. Here you went up 2, up 2, up 2. So right away I know it's linear. Now the explicit rule, since it's given me x, the y-intercept, remember, I can use mx plus b, and that's if I'm given the y-intercept, or I can plug a point in, x minus x1 plus y1. Either one I can use, but since I'm given the y-intercept, make it easy, 2x plus 6. The recursive, f of 0 is equal to 6, always state that. Then f of x equals my previous term, f of x minus 1. And what are we doing each time? Going up 2. Remember, this is always your common difference. The next one, here if I figure out how much I'm going up, I'm not going up an equal amount. So there's no common difference. And if you do it again, there's no common difference. But if I see if I multiply by 3, right, I get my common ratio, which tells me it is exponential. My explicit rule is, what's my initial amount here? My initial amount is 3 times, what's my common ratio? 3 to what power? The x. And since I'm given, again, the y-intercept, since I start at 0, I do not have to subtract 1 in the numerator or in the exponent. The recursive, f of 0 is equal to 3. So f of x is equal to my previous term times, what's my common ratio? 3. Done. And number 21, is this situation linear, exponential, or quadratic? If I count here, I have 1, 2, 3 toothpicks. Here, I have 1, 2, 3, 4, 5. Here I have 1, 2, 3, 4, 5, 6, 7. Then the last one, 1, 2, 3, 4, 5, 6, 7, 8, 9. So if I were to make a table here, 1, 3, 2, 5, 3, 7, 4, 9. If I look here, what do I have? I have a common difference of 2, which makes this linear. And the recursive rule would be f of 1 is equal to 3. Then f of x equals my previous term, right? Plus 2, my common difference. Explicit rule, f of x equals, f of x equals, what's my rate of change? 2 times, I'm going to use the ordered pair 1, 3. So it would be 2 times x minus 1 plus 3. I don't need the parentheses here. And how many toothpicks would be after stage 5? Well, f of 5 is 2 times 5 minus 1 plus 3, which gives me 2 times 4 plus 3, which is 11. And we are done. Okay, hopefully this helps. If you need more help, please make an appointment for period 2.